video, we want to find the best predicted value for a y value when there is no linear correlation between x and y. So this example states that suppose in a given set of paired data where the sample size n is equal to 6 and r is the linear correlation coefficient, is equal to 0.231. It was determined that the mean y value was y bar, that's the mean y value, is equal to 23.8, and the linear regression equation was calculated to be y hat is equal to 13.5 plus 2.8x. And we want to determine the best predicted y value for x is equal to 10. So one thing we want to know is there a linear correlation between this paired data? We're not actually given the data, but we are given r. And let's recall that r is the linear correlation coefficient. So we can use that to help us determine whether or not there's a linear correlation between the set of paired data. And we're also given that the sample size, the number of pairs of data here is n is equal to 6, which is a pretty small sample. And then I put a note over here. Generally speaking, if the absolute value of r is close to 1, then we say that there is a linear correlation. So we have a couple of different situations we can have with our paired data. It perhaps could look something like this, where the data is pretty close together, and it looks like there's a linear correlation, a line that goes through that data set. And that line's increasing as we read it from left to right. This is x, this is y. And so here we say r is near 1, and that there is a positive correlation. The slope of that line is a positive slope. So when we were to look at the linear regression equation, the slope would be a positive slope. We have a linear regression equation here, and this value in front of the x is positive. We could have another situation. So x and y, and perhaps our data looks something like that, and it looks like they're pretty close together, but the slope of that line is negative. Here r is near -1. And in this situation, there's a negative linear correlation between that paired data. So here r is near +1, here r is near -1. And we could have an additional situation where the data are scattered throughout. Here r is near 0, and there is no linear correlation between that paired data. So we'd like to take a look at that r value. And in our problem, we're given that r is equal to 0.231. So r is not close to +1 nor -1. It appears that r is near 0. So we would say that there is no linear correlation here. Okay. And when we're talking about how close to 1 or -1, as long as we have a large sample size, if it's somewhere close to 0.9 or -0.9, that's pretty close to the 1 or -1, but we'll look at a different way to approach this as well. So r is not close to +1 or -1, so no linear correlation, and that's what we're looking at. Find the best predicted value for a y value when there is no linear correlation. So we have no linear correlation between x and y here. So if there is no linear correlation, then our best predicted value will be simply the mean. So the best predicted y value in this case will be the mean. So that is y bar is equal to 23.8. 23.8. So I'd like to say one additional note on a different approach as opposed to just looking at R is equal to 0.2231. Another approach is to compare the absolute value of R with the critical value. The critical value can be looked up in a table in your textbook. So if you compare the absolute value of the linear correlation coefficient with the critical value, and if the absolute value of R is greater than the critical value, then you can say a linear correlation exists. If not, then you'll say that no linear correlation exists. So we're given the R value of 0.231, and I'll tell you from the table the critical value, and I'll denote this CV for critical value. The critical value, and it's based on the sample size, and our sample size here is n is equal to 6. The critical value in this case is 0.811. So we're comparing that, the absolute value of the linear correlation coefficient, and we want to know whether or not that is greater than the critical value. So it is not, so no. So then no linear correlation exists between the paired data. If that is the case, again, if no linear correlation, if there's not a linear correlation, then the best predicted Y value would be Y bar, the mean of the Y values, which in this case is 23.8.